So in this revision, we are given questions that we are going to consider on question number 2. This is part of our exponents and also the part of our sets. So without wasting much of our time, guys, let us quickly rush through these questions and see how we are supposed to attempt these typical questions. So question 2.1, you were given to simplify. So this whole part, you are supposed to simplify definitely to the simplest part that you can have as you are given. This you are not actually given the answer. Sometimes you're given show that this can give you a certain answer like this, but there you're not given. So it is you and your own ways of simplifying there until you get the simplest answer. All right, so what is it that we are given there? Let's consider our question 2.1. All right, so let's see. This question 2.1 where we are given 3 times 3 to the exponent of x minus 4 times 3 to the exponent of x plus 2. And everything that we are having is being divided to 3 to the exponent of x minus 3 to the exponent of x plus 1. So in this case, if we are to consider properly, we can see that we have the part of 3 to the exponent of x. As I said before, that is the major part that you're supposed to focus on. The 3 to the exponent of x. We have it here, right? We also have it hidden here where we've got 3 to the exponent of x plus 2. We also have another 3 to the exponent of x, also another 3 to the exponent of x. So meaning we can actually try to separate that so that at the end we can actually factor that 3 to the exponent of x. But how are we going to do it? All right, let's consider the first part, right? There's nothing that we can do. There's nothing being added. There's nothing being subtracted there. So it's just going to remain as it is. 3 times 3 to the exponent of x minus the 4 is not affecting the 3 to the exponent of x. So just write as it is. What is directly affecting there is this, the 2, x plus 2. So I say just separate the 3 to the exponent of x multiplied to the other part that is remaining, which is the 3 to the exponent of 2. So it is going to be 3 to the exponent of a 2 like this. All right. So if you consider the other revisions that you had, you can actually have much understanding from there. Other part, there's nothing that we can do. Just rewrite as it is. Minus, there is 3 to the exponent of x. Separate it plus 1. So separate that with 3 to the exponent of 1, which is remaining. As we know, guys, 3 to the exponent of 1 is just a 3. So at this stage, we can see what exactly we need. The 3 to the exponent of x. From the numerator here, we can see it properly there. It is common. We can factor it out. Yes, there are also numbers, the 3 and the 3 which is common, but just focus with 3 to the exponent of x for now. 3 to the exponent of x. Whatever that is going to remain there is going to cancel on its own, unless another factorization is to be made. So from the numerator, if I'm to take this one out, the 3 to the exponent of x, what am I going to remain with from the first one? I'm going to remain with a 3. From this part, I remove these 3 to the exponent of x. What am I going to remain with? Minus 4 times 3 to the exponent of 2. So take note there. This is a multiplication. 3 to the exponent of 2. So you're going to multiply this. Everything over what? From the denominator that we have, we can also have the same factorization. 3 to the exponent of x. It's the same. So which number we having here? There's just like a 1. We have a 1. So by factoring out the 3 to the exponent of x, which is common, what am I going to remain with here? I'm going to remain with a 1. Minus, factor this out, what are we going to remain with? Minus 3 to the exponent of 1. So this is what we're going to have, which is just same as 3. So you can actually simplify this, as we can see that by factoring out, is this a multiplication that we have? So we have the power to cancel these because they're the same. Under a multiplication, we can do that. So meaning to say you are left with this and also this in the denominator to be simplified. So you can actually simplify that. You can even use a calculator. You can just try to simplify stage by stage. That's 3 minus 4 times 3 squared. 3 squared, that's 9. 9 times 4, which is 36. Everything over 1 minus 3 to the exponent of 1 is 3. So 1 minus 3 is going to give us a negative 2 there. So meaning to say we're going to have minus 33 over minus 2, which is simply 33 over 2 that we are going to have there. So simply 33 over 2, or you can have it as 16.5. If you want, you can have 16.5 as a decimal, 16 and a half, the way that you understand from that. You can leave your answer in any format. So like I said, at this stage here, you can just use your calculator to simplify this stage and write your answer 33 over 2 at this stage. But there are those who want to simplify stage by stage. You can also do that way. So as we can see, that is what we're going to have at the end. We do not have any part of 3 to the exponent of x remaining because it was cancelled here. We canceled this. So this is what you're going to have at the end. All right, let's try and figure out on question number 2.2. Simplify without the use of a calculator. The calculator is not needed without. All right, so let's consider 2.21. They were given the square root of 5 over the square root of 5 plus a 2 plus 10, everything over the square root of 5. So take note here, square root of 5 is on its own. The 2 is on its own. It's not affected by the square root. There are so many ways that we can actually put into consideration as we are simplifying sets. There are laws which govern. There are laws which can be used considering the part of your sets. We can perform a normal addition as if we do not have those laws. All right, let's consider. There's so many ways. I'm going to explain just 2 ways for now. Let's say you are given 2 fractions that you need to add. Remember, you consider the LCD or the LCM, meaning to say we are going to take the denominator and this denominator. They're different, remember? It's like you are given one denominator as x plus 2, another denominator is x. What was going to be your LCD? You're going to take the x plus 2 and the x. So it was going to be x into x plus 2. So in the same manner, we are going to have it because we've got the square root of 5 on its own, and this is square root of 5 plus 2. So our LCD or LCM is going to be the square root of 5 into this, which is the square root of 5 plus a 2, like this. This is where you are. Where we can divide the LCD divided by this denominator that we have. So as you can see, this one and this one was going to cancel, but you do not cancel. You just imagine as if you're canceling that. You imagine that way, meaning to say you're going to remain with the square root of 5. What you remain with, this one, the square root of 5, you multiply it to the numerator. So it is going to be the square root of 5 times, in the numerator already, there is a square root of 5. So just multiply those two. All right, you move on, plus, you do the same thing. Our LCD as it is divided to this square root of 5. So as you can see, guys, the square root of 5 and square root of 5 was going to cancel. But like I said, do not cancel. Just imagine as if you are doing so. So this is going to remain the square root of 5 plus what? The square root of 5 plus 2. Multiplied to the numerator, which we have there, which is the 10. So that was going to be 10 into what is remaining after when you divide these two. You are remaining with this. Square root of 5 plus what? Square root of 5 plus a 2. So like I said, you do not cancel. You just imagine as if you are canceling this and this. You remain with the square root of 5. You multiply it to the what? To the numerator. So this is where we are. Like I said before, there are laws that govern our sets in terms of the multiplication, in terms of division. There are laws there which can be used where necessary. Yes, at this stage, yes, they've said without the use of a calculator, you can just use a calculator to multiply square root of 5 times square root of 5. Actually, no one is going to understand that you've used a calculator or not. No one is going to know that. But using the laws, it follows that the square root of a times the square root of a must give us a. If you're multiplying same numbers, the numbers under the square root, they are the same. Your answer is going to be that number under the square without the square root now. That number which was under the square root, but without square root. So as we are multiplying the square root of 5 and square root of 5, we can see that a 5 and a 5. So that was going to give us what? A 5. Or like I said, you can use a calculator. You can just multiply 5 times 5 is 25. And what is the square root of 25? Square root of 25 is what? It's 5. Let's say you understand that way. Okay? Then we move on to the other stage. We simplify this. Other stage, there's a bracket. There is a bracket to be considered. So the 10 must multiply everything, distribute by 10. So that's 10 times the square root of 5, which is going to give us 10 square root of a 5. 10 just multiplies the number outside, just like there's a 1. So it's 10 times 1, which is 10. For you to multiply the numbers, they must be all under the square root. Square root of a times the square root of b, which gives us square root of a, b under the square root. But here, one is not inside the square. The other one is inside. So please be careful. Just multiply 10 times 1. Then we move on, distribute 10. And the 2 there, that's 10 times 2, which is a 20. These are just normal numbers. So you can multiply that. That was going to give you a 20. Simplifying sets is different from simplifying fractions where you keep this denominator as it is, continue with that denominator as it is. When simplifying says, as you saw that the numerator, there we even expanded. Expand also the denominator. Maybe something might happen in the simplification. So also expand the denominator. So in the denominator, what is it that we have? The square root of 5 distribute both, that's a bracket. So we have to distribute square root of 5 times the square root of 5. Remember, we multiplied here square root of 5 times square root of 5, and we got a 5. So as you multiply the square root of 5 and the square root of 5, you're going to obtain a 5. That one is not going to change. All right, just like what we had before. Then we've got the square root of 5 to the what? To the 2. So it is going to be 2 square root of 5. Remember what I said before, you cannot multiply that number inside. You just multiply it outside, like just a 1 there. So it's 2 times 1, which is 2 square root of 5. So this is where we are. We expanded the brackets that we had in the denominator, which is something that you do not do when you are simplifying your normal algebraic fractions, as you understand. But these are sets. We must consider that. Considering the numerator, we can see that they are like terms, so we can collect our like terms. Which like terms are you talking about? The numbers, the direct numbers there, the 5 and the 20. So you can add these two. meaning to say we're going to obtain a 25. This 5 and this 20. These are like terms that we have there. So add these two. That was going to give us 25 plus what is remaining here, which is 10 square root of 5. Everything over 5 plus 2 square root of 5. So you can think of rationalizing the denominator as we work with the sets, that the denominator is not supposed to give us, or is not supposed to have a square root. But before you do that, before you think of that rationalizing of the denominator, consider factorization first. Can we factorize any part? By factorizing, you might see any part where we can cancel. That's the advantage of factorizing. So the denominator, as you can see, there's nothing common. Yes, there's a 5, then there's a 5, but this one is under the square root, so there's nothing that we can do. Looking into the numerator, these numbers that are outside the square root, the 25 and the 10, you can see that 5 is common there. So we can factor out the highest common factor, which is 5. So let's factor out 5. 25 divide by 5, that's a 5. Plus 10 divide by a 5, that's a 2. So we're going to have 2 square root of 5. Everything over what? 5 plus 2 square root of 5. So for the basics of your factorization, guys, also make sure that you consider your grade 10 work as we had basics of our factorization. So look now, as we have factored out the 5, we can see that there's something remaining which is common, which enables us to cancel these two instead of rationalizing the denominator as what we could have done. The factorization now makes it easier for us to cancel these two. So that's we've canceled this. We've got a 1 there. So simply that's 5 times 1, which is 5 over 1. As you cancel this, you're going to remain with a 1. So that's 5 over 1, which is what? Which is a 1, which is a 5 at the end. 5 divided by 1. So this is what we are going to have at the end from the whole of this simplification, the whole set that we had this part. Applying the basics of our addition of fractions. But as we are applying these basics of addition of our fractions, we are also considering that these are sets that we are working with. So we can also try and simplify the denominator. Another way that we could have simplified the same fraction is by rationalizing the denominators, as we are to consider that the first fraction, the denominator is having a square. Remember, I talked about rationalizing this. So we have to consider the first fraction and also the second one. If we are given two terms, just introduce a negative on the second term. So meaning to say, this was going to be the square root of 5. So, okay, rationalize the denominators in this case. So we are going to rationalize the denominators. All right, so let's try and see. So that was square root of 5 over the square root of 5 plus a 2. So how can we rationalize this? We are going to multiply by introducing, we introduce a negative there on the second term. So if you want, you could have write this as 2 plus square root of 5, then we introduce a negative on the square root of 5. So it's up to you guys. It's one and the same. Or you can just introduce the negative on the second term. So this is going to be the square root of 5 minus 2. All right. So let's say the part that we are using to rationalize. Square root of 5 minus 2 over the square root of 5 minus 2, like this. It's one and the same. Introduce a negative. Multiply both the numerator and the denominator. So this is just like we're multiplying by 1. We have changed. We have nothing has changed. Nothing has changed at all. It's still the same thing, because if you cancel these guys, we see we have the same thing. So when there are two terms, introduce a negative, all right? So this is going to be added to this other part, 10 over square root of 5. Rationalize also. So how do we rationalize this? We just have a single term in the denominator. So you multiply by that term when you have a single term. It's different from this part where we had an expression, this one plus this one. So we take this as two different terms in sets. So you must also understand the language of sets. So multiply by what? The square root of 5 over the square root of a 5. So this one we just consider as a single term. So we are going to simplify the first part and obtain whatever that you're going to have. We also do the same thing here. All right, so let's simplify, guys. As we can see, there's a multiplication, meaning to say the square root of 5 is going to multiply the numerator there, and these two will multiply each other. So that's, let's distribute square root of 5 times square root of 5. Guys, we saw this previously. That was going to give us a 5. As we multiply this, square root of 5 times the square root of 5 is going to give us a 5. I explained that from this law, square root of a times square root of a. All right, then square root of 5 times minus 2. That's minus 2 square root of a 5. Right? You are expanding the numerator there. Everything over what? The square root of 5 plus 2 times square root of 5 minus 2. As we can see, guys, this is a difference of 2 squares. This here it was from a difference of 2 squares. Remember, from your difference of 2 squares, if you are given 2 brackets, it's a plus b into a minus b, or it's a minus b into a plus b, whatever part that you start with. It was taken from a squared minus b squared. That is where it was taken from. So this is your a, guys. This is your b. This is your a. This is your b. So if it was taken from a squared minus b squared, meaning to say it was taken from what? A squared, the square root of 5 squared, minus b squared, which is the 2. So that's 2 squared. So we have simplified this. Yes, you could have expanded 2 brackets. There you take 2 brackets to expand them. Guys, whatever that you're going to obtain there is going to be the same answer as what you're going to have here. All right, so let's multiply the numerator to the numerator. Remember your relationship. 10 times the square root of 5. So that's 10 square root of a 5. Everything over what? The square root of 5 times square root of 5. We saw it here. It is going to give us what? A 5. So this is where we are. So let's simplify this. Like I said, you could have expanded 2 brackets there instead of using the difference of 2 squares concept. But if you understand that way, simplify using the difference of 2 squares. All right, so let's simplify. That's in the numerator. There's nothing that we can do. It is just going to remain as it is. 5 minus 2 square root of 5, everything over what? Square root of 5 squared means square root of 5 times square root of 5. So it is going to give us a 5. So square root of 5 squared is a 5. Minus 2 squared, that is 2 times 2, which is a 4. So 5 minus 4 is what? A 1. So this whole denominator is going to give us a 1. All right? Plus, there we can divide the 5 into the 10, which is 2. So that's 2 square root of 5. You can divide 10 divided by 5, which is 2. So guys, dividing by 1 has no effect. A over 1 is equal to A. B over 1 is equal to B. 2 over 1 is equal to 2. So there's no effect there. So meaning to say, this is going to remain as it is. 5 minus 2 square root of 5, as we are dividing by what? By 1. Then we add the 2. Don't forget this. 2 square root of 5. So this is where we are. Are we seeing something common? You can see that these are like terms. Square root of 5, square root of 5. So you're simply going to add these two. Minus 2 plus a 2, and that's a 0. Minus 2 plus a 2, guys, that's a 0. So it was going to give us 0 square root of 5. What is 0 square root of 5? That's a 0. 0 times any number. So these guys was going to cancel. So you remain with what? You remain with a 5. So as you can see, this is the same answer as what we had previously. So the simplification of sets, guys, it's in your hands. The laws that you understand, at the end, you're still going to obtain the same thing, same answer. All right, let's consider another question, which is on question 2.22, which is to simplify again without the use of a calculator. So the calculator is not needed here. So there we are given the square root of 7 to the exponent of 2011 minus the square root of 7 to the exponent of 2009. All right, so that is what we have being divided to the square root of 7 to the exponent of 2008. All right, sorry for that. Just going to remove this one. Then everything, we are going to add the square root of 7 on its own. Then it is being squared. This whole part is being squared. That is what we are given there. All right, so this is our question, guys, for 4 marks. Let's see. When working with this type of a question, try by all means to factorize in terms of what you are given. Remember, you are given a square root there. Sometimes you are not given this square root, this one. They don't give you this square root. They just give you as 7 to the exponent of this minus 7. That is how they write it. But in this case, they give you with a square root. So you separate in the same manner. Remember your square root of A times the square root of B was being taken from square root of AB. So as you are separating also with a square root, the two terms, whatever that you're going to have with a square root. All right. We are on that part of the square root that we are supposed to work with, the square root. The other thing that you're supposed to consider is of these exponents that we have, which one is the least or the smallest? We consider here on this one where we have got a single fraction. This one is on its own. So don't consider the square root of 7 for now. We are on these ones, on a fraction there. Which one is the smallest power, the smallest exponent? That is the 2008. So you work with the smallest one, the one with the smallest exponent. That is the one that you put into target. The one with the smallest exponent, you factor it out. You are going to factorize to factor out that. So in this case, we are going to factor out on this fraction, on the fraction, factor out the smallest one. So that's the square root, because there is a square root there. So you have also to consider the square root. So you're going to factor out 7, the square root of 7 to the exponent of 2008. If we were not having the square root, we're just going to factor out as this, 7 to the exponent of 2008, the smallest one. So this is the one that we are going to factor out on the fraction from the numerator. So meaning to say from our numerator in this first one, if we factor out the square root of 7 to the exponent of 2008, what are we going to remain with here? Guys, factorization is simply a division. So let's say you were given 7 to the exponent of 2011. Then you factor out 7 to the exponent of 2008. what were you going to remain with if you factor it out? What were you going to remain with? You were going to remain with the 7 to the exponent of what? Remember, factorization, what you factor out is what you divide with. So it was going to be like this. 2011, that's 2011 over what? You factored out this. So it was going to be 7 to the exponent of 2008. When dividing, what is that you do? You subtract the exponents. So 2011 minus 2008 is going to give us a 3. If you subtract, there's a difference of 3. The only difference that we have is that this one is under the square root. So as you factor it out, it was factored out under the square root. Meaning to say whatever that is going to remain also is going to be under the square root after factoring it out. That is the only difference that we have in this question. So meaning to say, as we factor out this, the square root of 7 to the exponent of 2008, here on this 2011, that one, you are going to remain with the square root of 7 to the exponent of a 3. Not just 7 to the exponent of 3, but under the square root. Everything is under the square root. Remember, I talked about the issue of what? Division. So you're going to do the same thing on this 2009. What were you supposed to do? You're supposed to divide. Remember, you're dividing by what? 7 to the exponent of 2008, where you simply subtract. So it was going to give you 7 to the exponent of 1. But everything is under what? The square root. So this, after factoring out 7 to the exponent of 2008 in this one, instead of us having 7 to the exponent of 1, it is going to be under the square root. Under the square root. Everything over what? Remember, we are considering the one with the smallest exponent. So it means our target is going to remain as it is. The square root of 7 to the exponent of 2008, this one, is simply going to remain as it is. All right, so this is where we are. And do not forget the square root of 7. There's nothing that we have done on this one. Just remain, it's just going to remain as it is. So plus the square root of 7 like this. All right, so this is where we are. And do not forget that everything was being raised to the exponent of a 2. So inside here, let us try to simplify where possible. Where possible. Which part? From the fraction here on the fraction, we can see that the 7 to the exponent of 2008 under the square root is the same. So you can cancel this since this is under a multiplication. So we are remaining with this bracket at the end. All right, so this is what you're going to have at the end. That is going to give us the square root of 7 to the exponent of 3 minus the square root of a 7 to the exponent of a 1, which is just a 7. So remember, we have canceled this. So it's just like a 1. There's nothing that is remaining. So this is canceled. So you're remaining with this bracket being added to the square root of 7. So from this bracket that we're supposed to have, guys, it's being multiplied by 1. So there's nothing there. So just add your square root of 7 being added to the square root of 7. This is where we are. And remember, everything is being what? Is being squared. So what can you notice here? These two are like terms. They're the same. It's just like you're given minus x plus x or x minus x. That's a 0 there. So it's the same thing with this one. These two are cancelled. So thus we are going to remain with the square root of 7 to the exponent of 3 being raised to the exponent of a 2. Remember your exponent of 2 there. No calculators, remember? But at this stage, we understand that the square root and the exponent of 2 neutralizes, guys. This is like square root of x raised to the exponent of 2 gives us what? X. What is inside of the square root? From our laws, we understand this is, remember, when you want to remove the square root, if you are given the square root of x and you want to remove, how do you remove this one? You square it, then you obtain what? X. So it's the same thing. There's a square root there. There's a 2, the exponent. So these two will just neutralize this, cancel this. That is what is happening there. The square root and the 2 cancels. So thus you're going to simply remain with what is under the square root, which is 7 to the exponent of 3. And what is 7 to the exponent of 3? If you multiply 7 times 7 times 7 3 times, it is going to give us 343. That's a single number that you're having there after simplifying all this. So these are typical exam questions. Questions can be of this nature. You can actually have questions of like this. So you have to revise as much questions as you can. Try to figure out how do they ask these questions. All right, let's consider another question, which is 2.3, simultaneous equation that we are supposed to solve for x and y simultaneously. But as you to consider this is not about the simultaneous equation, but what is it that is forming these simultaneous equations? They are formed from exponents. These are exponents. So if you consider the first equation that you are given there, this is 2 to the exponent of x times 4 to the exponent of y like this, which is equal to a 1. That is what we have on our first equation. And another equation that we are given is given as 4 to the exponent of y like this to the exponent of x, which is equal to 1 over 16. These are exponents. But in these exponents, we are supposed to form simultaneous equations. How is that possible? All right, let's consider the first one. I'm going to write equation 1, equation 2 after we have simplified and we have those normal equations that we are used to. So what can we do with the first equation that we're having there? They are separate. This is being multiplied. And to understand multiplication to be done is supposed to be a condition where we have the same bases, where we can simply add our exponents. So we have a 2 and we have a 4. We do not have same bases, so we cannot add these exponents for now unless we've got same bases. So how can we write 4 in the base of 2? That is the question. All right, so that's 2 to the exponent of x times 2 to the exponent of a 2. But there is a y which is on the exponent already, so you just multiply those two. And that is equal to 1. You're considering that 1 because of the base of 2. What about the 1 also because we are in the base of 2? So when it is like this, consider everything to be in the base of 2. So the 1, this one can be written in any base, in base of 10, in base of 2, in base. That is a number to the exponent of a 0. 2 to the exponent of a 0, 3 to the exponent of gives us what? A 1. So as we are focusing with the base of what? Of 2. So that means that's 2 to the exponent of what? Of a 0. The number that you are considering is 2. The exponent being what? Is 2 to the exponent is what? Is 1. All right, so this is where we are. Let's consider that we are multiplying. Like I was saying, we are going to add the exponents because the bases are the same. From the left-hand side, we can see that we have got the same base there. So add the exponents. So you're going to obtain 2 to the exponent of x plus 2y like this, which is equal to 2 to the exponent of a 0. Remember, if the bases are the same also, and being equal, if these two are equal, from the same basis, it means the exponents automatically are the same. A is equal to B. So in this case, we can say this part of x plus y must be equal to 0. So therefore, x plus 2y must be equal to what? Must be equal to 0. So this is what I'm going to call my equation 1. So that we'll see which method are you going to use at the end in solving of these equations. As we can see there, we now have a normal linear equation that we are used to. Not these exponents. We are not used to these exponents in terms of these simultaneous equations. So considering the second part, our second equation that is in the base of 4 is a 16. So you can consider the base of 4, it's a choice. You can consider the base of 2, it's also your choice. But in this case, remember exponent to exponent, you multiply. So that's 4 to the exponent of y times x is the same as xy or yx, just the same, which is equal to 1 over 16. In the base of 4, 1 over 16 is 4 to the exponent of what? A negative 2. Remember your exponents, guys. So that's 4 to the exponent of a negative 2. 1 over, that's a negative exponent. So there we can see that the bases are the same, the 4 and the 4. So therefore, what does it mean? Xy is equal to minus 2. Or yx is equal to whatever way that you have written there. The product of x and y must be equal to what? A negative 2. That's what I'm going to refer as my second equation. So I have got two equations. From these two equations that we had, we managed to rewrite in different ways representing the same x and y, but in something that we are used to. These are linear equations that we are used to. Yes, they can form quadratic equations at the end, but we have this understanding. So what can I do? All right, depending on the method that you are going to use, are you going to use the substitution method? Which method are you going to use? Because there we have an addition. Here, we do not have addition or it's a multiplication that we have. So in this case, it is best that you can make x the subject from both equations, then equate, or you make y the subject from both equations, then you equate them. So make either any one that you want. All right. So in this case, I'm going to make x the subject here. Make x the subject of the formula. Meaning to say, if we make x the subject of the formula, we transpose the 2y to the other side, it becomes a negative. So x is equal to minus 2y. That's 0 minus 2y. 0 minus 3, it's minus 3. 0 minus 4, it's minus 4. So 0 minus 2y is minus 2y. So this is what we are having from the first equation. You do the same thing on the second equation, make x the subject. So you're going to divide by y there, you divide by y like this. That's making x the subject because the product. So therefore, x is equal to what? Minus 2 over what? Minus 2 over y. These two representing the same x must be equal. This is x, this is also x. So meaning to say the remaining part must be equal also. This one must be equal. So you equate that. So equate the remaining part. That is the way that equate the remaining part. So equating the remaining part, it was going to give us an equation to say minus 2y as it is must be also. There is no way that we say this is x and this is x, and these two must be different. No, they must be exactly the same, these two, because they are from the same x. So that's why we have to equate them. So that's minus 2 over y like this. You have formed an equation which you can solve. Guys, we can see this is a -2, a negative. This is same like over 1 like this. If you see it properly, you can see that the -2 is in the numerator, this one. So it can cancel with this one. -2 can cancel. All right. Or let's say you don't understand that, just cross multiply. All right. You say that now you might have a confusion. Just cross multiply. Let's say you do not know. All right. Y times -2y is going to give us -2y squared equal to what? 1 times -2, that's a -2. So as we can see, guys, that -2 that I was talking about is back here. We can see it now properly. Cancel it. So that was going to give us a 1 there. So if y squared is equal to 1, what about the value of y? What about the values of y actually? You're talking about the values because of the squared. There are two answers that you're supposed to get. Introduce the square root, where we understand that the square root of any number is a plus or minus. So the square root of 1 must be plus or minus 1. That's having two answers there. Please take note. Meaning to say we've got two answers to say y is equal to 1 or y is equal to -1. Plus or minus, that is what it means. One is positive, another one is negative. From these values, we can now obtain the corresponding values of x when y is equal to 1. When this y is 1, what is the value of x? Remember our x, there are two equations. We can use this one or we can use this. We are supposed to have the same answer there. Anyone. X which is equal to -2y or x which is -2, we are supposed to get the same answer by substituting the value of y. All right, so let's just see from the first one. Remember, we're saying if y is 1. From the first one, x is equal to -2 times y, which is 1. That's a -2. If you're using the second one, that's x is equal to -2 over y, which is -2 over 1, which is what? -2, as you can see. You're having the same answer, same value. So just use one equation there. So when y is 1, x is going to give us a -2. You do the same thing if y is a -1. You substitute. In place of y, you're going to substitute a -1. So that was going to give us a +2. You substitute a -1. That was going to give us a +2 at the end. Same answer from any of the simplification that you're going to have. So the answers are going this way when x is -2, y is 1, or when y is 1, x is -2. And when y is -1, x is what? X is 2 at that condition. So these are the solutions that we are having at the end. But as you can see, guys, you are used to solving of the simultaneous equation. If you are given equation from this stage, if the question was here, if the question was from this stage, it was not going to be a problem because you just have to form your equations in a way that you can actually solve. To say you make y the subject or you make x the subject, you equate your equations. But they are not going to just give us direct equations like that always. Sometimes they give us in form of what? Exponents, like we saw before. It was from an exponential equation, you must have that equation that you are used to. You are the one who is supposed to create that equation. So as you are revising, working with the simultaneous equation, also figure out how questions are given so that when you are creating that equation on your own, you know how those equations can be presented as and how to solve from there. So like I said before, guys, let's do revise questions. Work as much questions as you can as you are preparing yourselves for the exams which are ahead of time.